Hey everybody, in this video we are going to be solving the equation sine theta cosine theta is equal to sine theta on the interval 0 to pi. So we only want the solutions that land in the first revolution of the unit circle. So I'm going to start with the equation. Sine theta cosine theta is equal to sine theta. And the first thing we want to do in this equation is we want to get 0 on one side of this equation. And so to get 0 on one side, I'm going to move this sine theta over to the other side of the equation. So I'm going to subtract sine theta from both sides, which will leave us with sine theta cosine theta minus sine theta is equal to 0. So we've done the first step and we have 0 on one side of the equation. Now when we look at the two terms that are on the left side of the equation, both of them have a sine theta in them. And so I'm going to take that common factor of sine theta and I'm going to factor that out from the left side of the equation. So I'm going to pull out a sine theta and then we'll talk about what's left on the inside of the parentheses after we factor that out. When we factored the sine theta out from the first term with the sine cosine, that leaves us with just a cosine theta. But when we factor the sine out from the second term, which is sine theta, or a negative sine theta, that leaves us with a negative 1. And sometimes people will forget that negative 1. I think it's clearer that when we distribute the sine back to the cosine, we get the sine cosine, which was the first term we have. But then you have to think about what needs to go right here so that if I were to distribute that sine back out, I would get this negative sine theta. So that's where that negative 1 is coming from. So now that we've factored the sine out, we have the left side written as a product of two different factors and the right side is equal to 0. So now we are going to set both factors from the left side of the equation equal to 0. So I'm going to set the sine theta equal to 0 and I'm going to set the cosine theta minus 1 equal to 0. The sine theta equal to 0 is already solved for sine theta, but the cosine equation is not. So I'm adding 1 to both sides of that equation to get that cosine theta is equal to 1. And now we're ready to look for some solutions. For sine theta equal to 0, that's going to happen along the x-axis of the unit circle. So I'm going to set up a unit circle here so we can visualize our solutions. So here's the unit circle. We know that sine is the y-coordinate of the unit circle. The y-coordinate is equal to 0 right there. That's at 0 radians or 0 degrees. And the y-coordinate is also equal to 0 right here at the point -1, 0. And that's at pi radians or 180 degrees. So from the first solution, we're getting that theta is equal to 0 or pi. And if you want to write your solutions in degrees, you could say that theta is equal to 0 degrees or 180 degrees. The second equation where we have cosine theta is equal to 1, I'll sketch another unit circle to help us visualize these solutions. Cosine is the x-coordinate, and the x-coordinate's only equal to 1 right there, which is again at 0 radians or 0 degrees. So I don't have to write that again. This could be radians or degrees because we already have it captured in the first set of solutions. So this equation has two solutions and there they are, both in radians and in degrees.